Hello and good day to everyone, and welcome to the another episodes on tips and workflow. In today's episode, I'm going to discuss on improving the accuracy of your simulation results. I know there are a number of factors that contributes on increasing the accuracy of the results. Few of are related to the CAD components and few of them are related to the inputs data. Now, what are the input data? It could be related to the processing parameters, it could be related to the mesh representation or the how precisely you are representing the geometry to the solver, and another part is the material data input. Yes, you heard it correctly. Now, you ask me what material data input or what things can go wrong with the material data inputs. Well, we will discuss in a step by manner or in a sequence. First most thing is that onto the processing parameters. Moldflow does allow you to put in the processing parameters like in for example like in filling control. If you want to do a correlations with your actual molding machines or take the data from the molding machines, you can fit in the data in terms of relative RAM speed profile or absolute RAM speed profile. That does take you closer to the actual reality. The another input is related to the how well we are representing the geometry to the solvers. Many times in the simulation or in the designed house, probably the user is working on a little bit different geometry versus what is been cut into the actual tool. I have myself experienced some of these issues or discrepancies between the two models. For a given example is related to the rib thicknesses. Maybe the rib thicknesses that been represented into the actual tool may vary with the actual simulations model, and that can relate to the issues like sink marks or short fill. Well, in that case, if you need to change the geometry on the flow on the fly, then Moldflow does allow you to make the modifications within the software with the help of normal or with the vector. Probably you can review my earlier videos and check how these geometries can be updated on the fly. Or probably if you want to get into the details of it or do a detail modifications, you can push in this geometry to the Fusion 360 without altering your feed systems or keeping your feed system intact, keeping your processing parameters intact, keeping your cooling channels intact, and you can push back to it and restart the analysis. And this was related to the inputs of the processing parameters, geometry representations. I did mention about the material as well. Well, in materials, many times you get a customized material database files from your resin manufacturer or your contract uh, tool manufacturer, or could be from the OEM as well. Having a UDV file is just not enough. Today I'm going to show you what things you should look into from the material point of view to increase the accuracy of your simulation results. I'm going to demonstrate this onto the generic material UDV file. Let's take an example of a generic ABS file here, and if you look into the details, it shows the information about the description, recommended processing, rheological properties. Well, everybody would have going through it, but also I'm going to talk about the completeness of these informations. Like for an example, in this UDV file, probably you would be highlighted with some of the red text over here that shows that this is in generic informations. It's not related to the exact grade which has been tested. So next time when you see something red mark in your UDV file, it's not very specific to that grade, but it's a generic property. Software design or the UDV file really didn't need this information specific to do the completeness. Well, Now the question arises, if this information is not complete, how it is going to impact on my results? I'm going to talk a bit on that as well. Let's check on to the other properties as well. Like for example, mechanical properties. Now when you're doing a warpage analysis, if your UDF file doesn't have the shrinkage properties in it, probably 50% of UDF file may probably not have that shrinkage properties, but mechanical properties would be there. And if the mechanical properties are in red, that means it's a generic. But in this case, it's not been highlighted as a red one. So it means it is very specific to this grade. Now, these mechanical properties would be used into your warp analysis. And if you are doing a simulation using 3D, it's much critical that mechanical properties will be contributing to the accuracy of your warpage results. Now all these things what I discuss will be represented in the form of material data completeness. Let's look at this tab. Now it shows that your filling data completeness indicator is gold. It shows the informations when this tested, and it also gives the information that this is going to expire at this date. It needs to be updated from the resin manufacturer prior to this date, or whoever has generated this information. To have a gold completeness indicator, your fill and pack should also have the gold indicator. It cannot have that fill and pack is bronze or silver and the warp is gold. No, it goes in a sequential manner. First the fill, pack and gold. Gold stands for the highestness of the completeness of the data. If you need to refer more information on this completeness indicator, just log into the knowledge.autodesk.com and search for the help on Moldflow Insight, and in the search type in that material completeness indicator like I did it here, and I'm going to check on to the what information it gives for us. Now this shows that material completeness indicator investigate the quality of the like for example, like a fill data completeness indicator investigate the quality of the viscosity, specific heat, and the thermal conductivity, because these are the basic things that are needed if you're running a fill analysis. And so as we also talk about those gold, silver, and bronze, and of course the unknown. So I will definitely recommend you to go through this web page and understand the criteria for the completeness for each of these analysis type, like fill. Like example fill, we need to have in viscosity data, specific heat data, and thermal conductivity data, and it also gets impacted the way it is been analyzed, when it is been analyzed, and the procedure been used to do the analysis. So next time when you're doing the analysis, it's worth checking the material completeness indicators. This is surely going to impact the accuracy of your results. I hope this video was useful and it will help you in improving the accuracy of your simulation results. Thank you. Have a great day.